This problem in the packet is very similar to number 39. If you recall how to do this one, what we need to do again is we can't just cancel out the logs with a base 2. I can only do that if there's a single log on one side. And so what I need to do first is condense this into a single log. And if you remember that addition, again, condenses to multiplication. So I'm going to write log once because we're condensing it to a single log. And what are we condensing it with is x times x plus 3. And we have here is log base 2 of 10. I guess I should have this here. Now, because we have just a single log on both sides, now we can cancel that out. And remember, to cancel out a log base 2, we have to use an exponential base 2. So to cancel this out, I'm going to just use a big 2. Basically, we're exponentiating with the base of 2. And now these are opposites. So here we have the 2 and the log base 2 cancel out. What should we do to one side? We do the other. And we see, oh, same thing happens here. I can just cancel that out. And so what are we left with? Well, I'm left with just the x times x plus 3 on the left side. And on the right side, I have 10. And if I distribute this, I get x squared plus 3x is equal to 10. And again, it's a quadratic, which we can solve by factoring. So I'll subtract the 10 first to make it equal to 0. And now we'll factor this out. So let's see. The front I know is x times x. The back I need, let's maybe try 5 and 2. Multiplies to 10. And let's see what happens here. If I wanted to add it to a positive 3, I'll try a plus 5 and minus 2. The inside gives me 5x. The outside gives me minus 2x from x times negative 2. And that adds up to positive 3x, which is what I wanted in the middle. So this is correct. So now we just use the zero product property to solve this, which tells us that x plus 5 is equal to 0, or x minus 2 is equal to 0. And so x is negative 5, and x is equal to 2. Negative 5. Now we just always have to check for extraneous solutions whenever we're solving a log equation. We want to make sure that we're not taking the log of a negative number, because we can't do that. So here, when I look at this one, if I plug in negative 5 in our head, I can see right away that taking log base 2 of negative 5, that's taking the log of a negative. I can't do that. So that's not the solution. And if I plug in 2, well, I can take log of 2. I could also take log of 2 plus 3 is 5, so that's a positive number also. So this one is okay. And so this one is our solution, is x equals 2, which is D.